Hey Mojotonians, it's Andy Johnson back again, part 2, board construction and basic soldering techniques. Okay, so if you notice what we have here, I've already put a couple of components for the power, for the cathode for the 6v6s for the output tube, power tube, and one of the filter caps in here. And I just wanted to show you the basics. If you want a good looking build, there's of course 100,000 different ways you can do this, and everybody builds the amp differently, and that's what's really cool about the class is you get to see that, and it's really entertaining because you'll have 20 beautiful looking amps, but they're all built a little bit different, and they're a reflection of the personality of the person that built it. It's a very unique thing. But as we see here, I'm going to put the backer board out of the way here. So as we see here, started with, again, I described in my last video, starting from the left, moving to the right. Got the cathode cap in here, or excuse me, cathode resistor with bypass cap, and the first filter cap. And what I want to do is I want to go over basic soldering techniques with you. Okay, so I like to use a 60 watt variable. Let's see if I can get a picture of that here. I don't know if I can get that over here. It's an old Heiko 936 I like to use, and Heiko makes some remarkable stuff. If you guys can find it on eBay. I don't know if they make these anymore, but I've had that for 15 years. Fantastic. They still make the tips and iron replacements for it. But again, 60 watts. I like to run around 450C, I believe it is, which is pushing 700, or around 400, 425, which is pushing about 700, 750 Fahrenheit. That way, because electronically speaking, this is a kind of a large area to heat up. But we need to be in that envelope to where we can heat up the lead itself as well as the eyelet, but we don't want to overheat the component. Fortunately, the components that we use in the 5E3 are very durable. It's high quality everything. Most of these things are, I believe they're 350C or right at, maybe the carbon comps are a little bit less than that, but I have yet to have anybody actually burn up a component by soldering it. Okay, now if you see what I've done here, just a couple things for a solder. The resistor on this kit is wide enough to go from eyelet to eyelet, but I don't know, it's something about this. I like putting the resistor on top. You don't have to, you can put it beside, but one thing you don't want to do is put the actual cap on top of the resistor, because if a tube starts to fail or you have a short in one or both of the tubes, this resistor is going to draw a lot of current on the cathode, and it's going to get very hot. And where does heat go? Where heat rises. So anytime you keep that heat away from that cap, of course, if the cap was on top, the heat would rise to the cap. Of course, you don't want that because you might have component failure down the road, and it happens. It's not that big of a deal. You replace a component and that's it. But this is one of the things I like to do. It's just just a aesthetic thing, really. And also put all your components on your board. You want to make sure that you're able to read them in the future. If you notice, I put the filter cap, with all the information up, as well as the Sprague atom, and of course that's kind of bright. Sorry for the glare. The actual cathode resistor for the preamp or for the output tube. Okay, so a good practice is that I like to use a flat blade tip. That way you can disperse the heat very evenly. And I use a Kester 44 solder. Now we'll go more into that after probably in the next video, and why we like to use this. Okay. So when we solder, what we're doing is, if you notice, there is no solder on the end of this tip. So I will have a wet sponge by my workstation, which you can see here on my holder. And it's a good practice to, when you pull your iron out, you wipe both sides on the sponge rapidly. Make sure it's clean, which it is. I'm going to add a little bit of solder to it. And what that does is that's going to transfer the heat onto the eyelet. Okay, I'll let that set for 3 or 4 seconds. I'm going to add some solder, let it flow, and you'll actually start to see it puddle down into the actual eyelet, and that's it. Now, when you look at this solder, one thing that's really cool about this solder, this Kester solder that we use, is basically the same type they use back from 50 to the late 60s. I think Fender or even Marshall, I think, used some of that stuff. is that you know you have a good solder joint when it's real shiny, like it is here. Keep going the wrong way again. Okay, and it's slightly convex. Now when we look at the back side of it, you'll notice it's almost flush, and you don't see any voids. If you were to look at this really close, I can't zoom in on it, but you don't want to see any voids around the lead that's going through the actual eyelet. Okay. Now I don't normally solder all the eyelets when I'm constructing the board. The only things I ever really solder is things that need to be kept in place. Because you're going to move flipping the board over, forward, backwards, upside down, you know, to get all the traces and the lead links on it. But I like to do this so you can see what a good solder joint should look like. Now, if you notice around the actual, I don't know if you can see it on the film, but it looks like there's a big wet mark around where the eyelet is, where it was heated up. That's two things. Usually, 99% of the time, the wet you see is the actual flux inside the actual solder. This is if you're looking under a magnifying glass, you would actually see the center of this solder is hollow and it has a acid flux in it. So that's why they call it an acid core flux. The flux cleans the solder joint, and when the flux dries, it's very shiny, and it has a very opaque brown tint to it, or tan tint to it. I guess be kind of like tea that surrounds the actual eyelet, which is a good thing. You want that. Okay. Now the reason I piggybacked this actual resistor on the cathode resistor was because as we get down further into the preamp, you'll notice I'll actually start piggybacking resistors on top of cathode bypass caps like this, because and I'll show you real quick, a lot of the vintage Allen Bradley and stack pole resistors that were used back in the 50s and 60s had lead links that were about an inch longer than what we can get now, unless we use NOS stock. Okay, so when we look at this, you see the lead length? Yeah, it barely makes it from eyelet to eyelet. So if you notice on the actual wiring diagram, we piggybacked the resistors, cathode resistors, across the bypass caps on the cathode resistors, on the cathodes of the preamps. That way you don't need to stretch or span all the way and just tack them in place. There's a firm connection there. Now when we get those in place, the reason I did this is I want to show you, on this particular one, there is a slight gap between the back and the front. Now the case of these, if you were to actually take this heat shrink off of it, you will see that the case is actually aluminum. And you can see it more on the King caps when you look at the back of it. The aluminum is actually brazed to the lead coming out of the actual cap. So that, I know that this lead is ground, and 99.9% of the time, all the caps that are actual electrolytics like this that are polarized will have aluminum grounded cases. Okay, now on the positive side, you notice there's a rubber stopper, or excuse me, an insulator. You rarely see it on the small Sprague atom there. Sorry, I'm going the wrong direction. That's an insulator for the positive side. The reason I bring this up is because a lot of times, a lot of failures I see in amps is that people will run their soldering irons too hot, and what actually happens is that they're not thinking about it too much, and they'll run right here this lead of the resistor or the cap right up, or I should say resistor on the cap rather, right up on the positive side. Now this is heat shrink tubing. It's plastic. It's a high temperature plastic, but it's still plastic and it will melt. If your soldering skills aren't that great, or you weren't thinking about it and you leave it on there for 1 second too long, what happens is that this heat shrink that has all the information on it will actually melt, and you will short this positive lead that's coming off the cathode directly to the tube. You'll short that to the actual case. So you're shorting your positive to the negative and bypassing the resistor entirely. Very common thing. So I like to be very careful when I'm soldering these. I'll leave at least a 1/16th, a 3/32, or even in large current ones, you want to leave an 1/8 inch. You know, it's just a matter of personal preference. So in this case, I'll leave the resistor off to the side, and I'll solder. I'm applying heat, a little bit of solder. I'm going to rotate this up, take the heat off, and hold it. and it will actually hold the resistor in place right there. Okay, and then at that point, all I need to do is go back in and solder the second joint right to it. And I'm watching it the entire time for solder flowing onto the actual lead. And this, sorry, everything's backwards. This is what we wound up with. If you notice, there's a gap in the front and a gap in the rear. It's soldered well. Of course, the front's a little bit, I could have done that a little bit further apart, but I think it's fine. That's how we do that. Again, heat rising, and keep it away from, you know, the one killer among all electronics is heat. And I'll get more into why there are some issues with tweed amps in particular, especially vintage ones. We'll get more into that later on. So, but to reiterate upon the soldering, I'm going to go over this again. Okay, I pick it up, I wipe it both sides, come down, apply heat. 1, 2, 3, 4, maybe. Apply solder, let it flow, and boom, there you go. Don't move the component, let it dry for about 3 to 5 seconds, and there you go. And that is a correctly soldered component. You see that? Okay, and that is the very first part of our fiberboard build. It all starts with that. That easy. Okay. Well, next point, I'll be constructing a little bit more of the fiberboard and explaining what's going on, why the component placement is the way it is. Okay. Thank you for watching. Check me out next time.